My talk today is the fifth installment in a series of video presentations on the topic of thermodynamic non-idealities in CO2 capture using Calgary Framework 20. Parts 1, 2, 3, and 4 are already available on my YouTube channel. Just to recap, in part 1, I elucidate the origins of thermodynamic non-idealities for adsorption of mixtures of CO2 and water in CAF 20. I identify the existence of two different scenarios that are prevalent at low percentage relative humidities and at high percentage relative humidities. At low percentage humidities, the mixture adsorption favors CO2 and disfavors water. However, the scenario is completely different at high percentage relative humidities, wherein the adsorption of CO2 is suppressed significantly by water. This is caused due to significant hydrogen bonding effects between pairs of water molecules. In the second part, I discussed the real adsorbed solution theory modeling of CO2 water mixture adsorption in CAF 20, and I show the vast differences between RAST and IAST predictions. The IAST fails miserably. In part 3, I discuss both nitrogen water adsorption in CAF 20 and adsorption in CO2 nitrogen mixtures in CAF 20. These two mixtures behave differently. Mixtures of CO2 and nitrogen behave ideally, and the IAST predictions are of excellent accuracy. On the other hand, adsorption of mixtures of nitrogen and water have all the characteristics that are analogous to mixtures of CO2 and water. Two different scenarios are prevalent, as I had already explained in part 3. In part 4, I discussed the modeling of transient breakthroughs of mixtures of CO2 and water in fixed beds packed with CAF 20, and I show the significant differences between the predictions of RAST and the IAST in modeling transient breakthroughs. The RAST modeling is in good agreement with the experimental data of Nguyen. All parts 1, 2, 3, and 4 are detailed in my paper, Separation and Purification Technology, that is referenced here. In this fifth part, my focus is on adsorption of ternary mixtures of CO2, water, and nitrogen in CAF 20. For explaining this mixture adsorption, I use the molecular simulation data of Gopal Swamy and Guillaume Morin, published in ACS Applied Energy Materials, and that is referenced here. The molecular simulation data for the component loadings of CO2 indicated by the red circles, water indicated by the blue triangles, and nitrogen indicated by the green squares. The component loadings plotted as a function of percentage relative humidity are from figure 5A of Gopalswamy. I compare the molecular simulation data with the predictions of the IAST using unary isotherm fits. Again, we see the prevalence of through different scenarios at low percentage relative humidities. The IAST predictions for both CO2 and nitrogen are in excellent agreement with the CBMC simulation data. On the other hand, the water loadings are significantly lower than the IAST predictions. The scenario is completely different at high percentage relative humidities, in which the component loadings of water exceed those anticipated by IAST. On the other hand, the IAST overestimates the loadings of CO2 and nitrogen. In other words, at high percentage relative humidities, the adsorption of both CO2 and nitrogen, I emphasize, both CO2 and nitrogen are suppressed due to co-adsorption of water. Another way to explain this phenomena is to plot the mole fraction of CO2 in the adsorb phase as a function of the percentage relative humidity. We delineate two different scenarios at percentage relative humidities lower than about 40%. The adsorb phase is significantly richer in CO2 than anticipated by the IAST. On the other hand, at high percentage relative humidities larger than 40%, the adsorb phase is significantly poorer in CO2 than anticipated by the IAST. The same holds for nitrogen adsorption. At percentage relative humidities lower than 40%, the adsorb phase is richer in nitrogen than anticipated by the IAST. On the other hand, for percentage relative humidities larger than 40%, the adsorb phase is significantly poorer in nitrogen than anticipated by the IAST. So, to summarize, the adsorption of ternary mixtures of CO2, water, and nitrogen is strongly dependent on the percentage relative humidity, and two different scenarios are prevalent at low percentage humidities and at high percentage humidities. The next part in this series of thermodynamic non-idealities in mixture adsorption and CAF20 will examine mixtures of CO2, water, and methane. Such mixtures are important in CO2 capture from natural gas streams under humid conditions.